forceful response. So actually we are having some differential equation with some input x of n is equal to something. Okay now forceful response is generally it is a combination of particular solution plus and homogeneous solution. It is a combination of particular solution. P stands for here particular solution and H stands for homogeneous solution. Right? So in order to calculate the homogeneous solution, the input must be 0. As we know that whenever you want to calculate the homogeneous solution, you have to put the input must be 0. So if we can write here y of n plus 2 something like 2 into y of n minus 2 plus y of n minus 2 equal to 0. Then replace the y of n with respect to lambda to the power of n and y of n minus 1 with lambda to the power of n minus 1. So you can write that lambda n plus 2 into lambda to the power of n minus 1 plus lambda to the power of n minus 2 equal to 0. Now by taking lambda to the power of n minus 2 as common, then you have lambda square plus 2 lambda plus 1 equal to 0. Then you have to find out the factors for this lambda factorization. So what are the roots we have got? Lambda equal to minus 1 and minus 1. Okay, so lambda here we are having equal roots, simple and equal roots. Whenever you are having equal and simple roots, then the homogeneous solution by h of n is equal to lambda. What is the general equation? It is lambda to the power of n into c1 plus c2 into n. So what is the lambda value here? We are having lambda value is minus 1. So I am replacing that to lambda with minus 1. Minus 1 whole to the power of n into c1 plus c2 into n. So first of all you have to consider this main equation has equation 1 and this has equation 2. Please follow the equation number also as it is. Okay, so this is equation 3. So up to here we have completed that finding the homogeneous solution. Yesterday we have discussed about this homogeneous solution. It's up to here, it's yesterday's part only. Now today we are going to discuss about the particular solution. The combination of homogeneous and particular solution will be your forced response. Right? So how to find out the particular solution? So actually here we are having y of n minus 2, nothing but it is second order equation. We can say that it is second order equation because suppose if you are having y of n minus 1, then it will be first order equation. Okay, and here what is the input? It will be the first order because x of n minus 1 you are having. Adhamaitunda? Okay, so here yp of n is equal to I am having the solution for this particular solution I am telling, right? So the solution for the input, whenever you are having input as u of n stands for unit step signal. Then the result will be yp of n by particular solution is equal to k into x of n, where k is a constant. What is the input here? X of n. What is x of n? R to the power of n into u of n. Right? So now yp of n is equal to, just I am substituting that value. X of n, k into r to the power of n into x u of n. Now this is fourth equation. Substitute this equation in first equation again. Substitute equation 4 in first equation. Then you have y of n, that is nothing but y of n and k into x of n plus y 2 into y of n minus 1 you are having. This is n minus 1 u of n minus 1 plus k into n minus 2 and u of n minus 2 is equal to, what is it? X of n is equal to half to the power of n into u of n plus half to the power of 1 into u of n minus 1 because we are having 1 there. Okay, so this 1 minus 1 and 10 అవుతుంది u of 1, right? So you will have whenever n equal to 2 and this is you will have k into half to the power of 2. Same, I am substituting n values in equation 1 with the input k into x of n. This is the particular solution whenever you are having input as this much. So we have to find out the k value here. From this equation you are going to get what is the k value? K equal to 1 by 3. K equal to 1 by 3. Substitute this in equation 4. Where is the 4? Yeah, this is the fourth equation. Fourth equation. So yq of n is equal to k. What is the k value we got here? 1 by 3. So 1 by 3 into half to the power of n into u of n. Then you have this is fifth equation. Okay. Next substitute 3 and 5. Equation 3 and 5 in equation 2. What is the equation 2 here you are having? This is the sum of homogeneous solution plus particular solution. Sum of homogeneous solution plus particular solution. Substitute that, then you will have sixth equation. So it will be sixth equation. Substituting third equation and fifth equation in equation 2, you will have sixth equation. This is the equation for the sixth. That is nothing but your forced response. Now we have to calculate initial conditions like y of minus 1, y of minus 2. Yesterday we got, right? So we have seen that y of minus 1, y of minus 2 already is given in the problem. Now we have to calculate by our own. Okay. So initial conditions ఎలా calculate చేయాలి? Substitute n equal to 0 in equation 1. Nothing but first equation. So when you substitute that, it will be y of 0 n equal to 0. I am substituting y of 0 plus 2 into y of minus 1 plus y of minus 2 is equal to x of 0 plus x of minus 1. Then what is that x of 0 here? From this you will get x of 0 is equal to half to the power of n, nothing but n equal to 0. Anything to the power of 0 is 1. Then u of 0. What do you mean by u of 0? Unit step signal at 0. Unit step signal at 0. So you will have this one. So we don't know the value of y of minus 1 and y of minus 2 we don't know, right? So you have y of 0 is equal to x of 0. How much you are getting there? So what is that x of 0? Let us take the x of 0 is equal to half to the power of n into u of n. When n equal to 0, it will be half to the power of 0 u of 0. So it will be 1 only. So x of 0 equal to 1. Then what is the value? Y of 0 is equal to x of 0 is equal to 1 v1. Okay. Now when you substitute that n equal to 1 in equation 1 again, equation 1, if you substitute n equal to 1, there will be y of 1 plus 2 into y of 1 minus 1 is 0 plus y of minus 1 is equal to x of 1 plus x of 1 minus 1 is 0. Right? So you have this one y of 1 plus 2y of 0, y of minus 1. And we know the value of y of minus 1. So we can cancel it. Then you will have y of n. 2 into what is the y of 0? Just now we got that y of 0 is 1. Substitute that value here. 2 into 1 which is equal to again x of 1. Then we don't know the value of x of this one. From here we have to calculate. What is the value of x of 1 here? Half to the power of 1 into u of 1. What is the value of u of 1? From any value, for any value, unit step signal will be of magnitude 1 only. So half to the power of 1 is nothing but it will be half only. Right? So if you simplify that, you will get y of 1 is equal to something minus half or minus 1 by 2. That is the value for the y of 1. Now we got different values like y of 0 and y of 1 we got. Right? Next we have to calculate the coefficients. Actually we are having the coefficients like what is the equation now? Lambda to the power of n into c1 plus c2 n. So we have to calculate here c1 and c2 coefficients. Now how to calculate? Please remember that in order to calculate the coefficient c1 and c2, just replace n equal to 0 or n equal to another value, any other values like n equal to 1, n equal to 2, n equal to minus 1, n equal to minus 2 in equation 6. Whenever you want to calculate the coefficient c1, c2, c3 like that, then you have to substitute the different values of for n in equation 6. Okay, whenever you are calculating that output y of 1, y of 0, y of 2 like that, what we are doing? We are substituting n equal to different values in equation 1. If you substitute n equal to various values in equation 1, you are going to get the output response that y values for n in equation 6, then you are going to get coefficients. Let us take equation 6, that is here we are having, right? So substitute that n equal to 0 now. Whenever you are substituting y of n equal to 0, y of f is equal to 0, and this will be 0, u of 0 plus minus 1 whole to the power of 0, and c1 plus c2 n you will have. c2 n equal to 0 means you will have only c1. Then here you have to remember that the forced output is equal to your output, normal output, y of 0 is equal to 1, because already we calculated here, y of 0 equal to, already we calculated here. From this you are getting. For y of 1 is equal to, now we are considering it is y of 0. Then we are taking that y of f of 0. Suppose if it is 1, it will be 1. Suppose if it is 2, it will be 2. Like this. Okay. Then what is the value you are getting? 1. So if you substitute that, then you will get c1 equal to 2 by 3. And if you substitute n equal to 1 in equation 6, then you will get c2 equal to something. If you substitute these c1 and c2 and everything in the main equation, then you are going to get this is the equation for forced response of a given system. Forced response of a given system. What is the definition for the forced response? It is a combination of particular solution plus homogeneous solution. In order to calculate the homogeneous solution, the input should be equal to 0. Then you have to find out the roots and everything. Okay, so this is about the forced response.